NASA's IXPE imager reveals mysteries of rare pulsar. An international team of astronomers has uncovered new evidence to explain how pulsing remnants of exploded stars interact with surrounding matter deep in the cosmos. Using observations from NASA's IXPE and other telescopes, this makes it a transitional millisecond pulsar, said researcher Maria Cristina Baglio of the Italian National Institute of Astrophysics Brera Observatory in Morate, Italy, and lead author of a paper in the astrophysical journal Letters illustrating the new findings. Scientists based in the US, Italy, and Spain set their sights on a mysterious cosmic duo called PSRJ 1023 plus 0038, or J1023 for short. The J1023 system is comprised of a rapidly rotating neutron star feeding off of its low-mass companion star, which has created an accretion disk around the neutron star. Other telescopes contributing data included the Carl G. Jansky Very Large Array in Magdalena, New Mexico. This neutron star is also a pulsar, emitting powerful twin beams of light from its opposing magnetic poles as it rotates, spinning like a lighthouse beacon. The J1023 system is rare and valuable to study because the pulsar transitions clearly between its active state, in which it feeds off its companion star, and a more dormant state, when it emits detectable pulsations as radio waves. Previous models had indicated that the X-rays come from the accretion disk, but this new study shows they originate with the pulsar wind. The answer would inform broader theories about particle acceleration, accretion physics, and the environment surrounding neutron stars across the universe. And particles accelerated near the speed of light that hits the accretion disk. Sign up for our free newsletter and get updates on breakthroughs, innovations, and research that matter daily or weekly. Alabama. These new observations show that the pulsar wind powers most of the energy output of the system. Transitional millisecond pulsars are cosmic laboratories, helping us understand how neutron stars evolve in binary systems. Polarization is a measure of how organized light waves are. DOI 10.3847 204-18213. Add 7D2, they looked at X-ray polarization with IXPE, the only telescope capable of making this measurement in space. Insights from these observations could help refine theoretical models describing how pulsar winds generate radiation and bring researchers one step closer. Baglio and Cody Zalotti agreed to fully understanding the physical mechanisms at work in these extraordinary cosmic systems, and compared it with optical polarization from the European Southern Observatory's Very Large Telescope in Chile. IXPA launched in December 2021 and has made many observations of pulsars. But J1023 was the first system of its kind that it explored. The big question for scientists about this pulsar system was, where do the X-rays originate? The source surprised them. The X-rays came from the pulsar wind, a chaotic stew of gases, shock waves, magnetic fields. To determine this, astronomers needed to measure the angle of polarization in both X-ray and optical light. NASA's NICER and Neil Gehrels Swift Observatory provided valuable observations of the system in high-energy light. The result? Scientists found the same angle of polarization across the different wavelengths. That finding is compelling evidence that a single, coherent physical mechanism underpins the light we observe, said Francesco Coti Zalotti of the Institute of Space Sciences in Barcelona, Spain, co-led author of the findings. This interpretation challenges the conventional wisdom about neutron star emissions of radiation in binary systems, the researchers said. Discover the latest in science tech. In space, with over 100,000 subscribers, who rely on PICE.org for daily insights. Email IXPE has observed many isolated pulsars and found that the pulsar wind powers the X-rays, said NASA Marshall astrophysicist Philip Corrett, principal investigator for IXPA at NASA's Marshall Space Flight Center in Huntsville. Astronomers continue to study transitional millisecond pulsars, assessing how observed physical mechanisms compare with those of other pulsars and pulsar wind nebulae. And more information. Maria Cristina Baglio, et al. Polarized multi-wavelength emission from pulsar wind accretion, disk interaction in a transitional millisecond pulsar. The Astrophysical Journal Letters. Journal information. Astrophysical Journal letters provided by NASA.